All right, welcome to today's Explainer. We're jumping straight into the absolute darkest, most extreme, and honestly most profoundly mysterious objects in our entire universe. We are going to push way past the standard limits of astrophysics today to discover what actually happens when matter reaches its absolute, literal breaking point. Imagine a destination out there in the cosmos where all our normal conceptions of time and space just completely break down. This isn't sci-fi, you guys. This is a very real destination out there in the dark. And today, we're traveling straight into that ultimate no man's land. Section 1. The Cosmic Abyss. Establishing the scale of the dark.
Okay, so before we get too close, we really need to understand the sheer, terrifying scale of what we're dealing with here. 66 billion. That is the mass of a supermassive black hole known as TON 618 measured in solar masses. Think about that. That means this single object contains the mass of 66 billion of our suns. To put that into perspective for you, if you packed our entire solar system, the Sun, Jupiter, Earth, all the way out to the icy Oort cloud, into a solid sphere, it still wouldn't come anywhere close to this mass. It's wild. So remember, black holes aren't actually holes at all. They aren't empty space. They're the exact opposite. They are unimaginably huge concentrations of matter packed into terrifyingly tiny spaces.
Section 2. Myths versus reality. What black holes are not. Right, let's dive into this and unpack some pop culture baggage before we get any closer. First up, black holes are not cosmic vacuum cleaners. They don't just aggressively suck everything around them into oblivion. In fact, from a safe distance, a black hole's gravity acts exactly like any other object of the exact same mass. So, if we were to magically replace our sun right now with a black hole of the identical mass, Earth wouldn't be sucked in. I mean, sure, we'd freeze, absolutely, because the light would be gone, but our planet would remain perfectly in its orbit, happily circling a dark sphere. And despite what your favorite sci-fi movies love to tell us, they aren't guaranteed wormholes or portals to other dimensions either.
Section 3. Crossing the event horizon. The point of no return.
Now that we know what they aren't, it's time to approach the edge, the event horizon. This is the ultimate boundary in space-time. Now, it's not a physical, solid surface like the crust of the Earth. You couldn't just land a spaceship on it. It's more like a perfect one-way membrane. Once you, or a star, or even a beam of light crosses this invisible threshold, the gravity becomes so intensely powerful that the escape velocity exceeds the speed of light. And since absolutely nothing in the universe can travel faster than light, well, nothing gets out. It completely isolates the interior from the rest of the universe. Now, what's really interesting here is how Einstein's theory of general relativity creates a massive paradox. It creates two completely different but equally true realities depending entirely on your perspective. If I'm the distant observer safely hanging out in my spaceship, watching you fall toward the event horizon, I never actually see you cross it. Because extreme gravity heavily warps time, an effect called gravitational time dilation, I would see your clock tick slower and slower. To my eyes, you'd appear to freeze right at the very edge, slowly fading to a deep, invisible red as the light stretching from you loses energy. You literally become a ghost on the edge of the abyss. But for you, the infalling observer, your watch ticks perfectly normally. You'd cross the event horizon in a finite amount of time without feeling a single bump in space-time. But your smooth ride doesn't last long. As you plunge deeper, the physics shift drastically. If you were to fall feet first into a stellar mass black hole, the gravity pulling on your feet would be vastly stronger than the gravity pulling on your head, simply because your feet are a bit closer to the center. This creates extreme tidal forces. Imagine the force that causes the ocean tides on Earth, but magnified by trillions. You're squeezed horizontally and stretched vertically. Astrophysicists, and I love this, call this very real, very terrifying process spaghettification. You are literally drawn out into a long, incredibly thin string of atoms long before you ever hit the bottom.
So, our atoms are accelerating inward through the darkness. The gravity is pulling harder and harder. Space itself is rushing inward faster than the speed of light. Which leads us to the ultimate question: what actually lies at the absolute center?
Section 4. Inside the singularity, where math breaks down.
We are now entering the bleeding edge of theoretical physics. According to Einstein's general relativity, all that mass, the stars, the gas, the planets, and our poor spaghetti-defied astronaut, is inevitably crushed into a singularity. This is a region of zero volume and infinite density. Just think about that concept for a second. An entire star's worth of mass crushed into a space literally smaller than a single electron.
The curvature of spacetime becomes infinite here, which essentially means the math of our current laws of physics just gives up. It completely breaks down.
But nature is rarely that simple, is it? An infinitely small point singularity only really exists in a non-rotating black hole. But in the real universe, everything spins. Stars spin, and when they collapse into black holes, it's kind of like an ice skater pulling their arms in. They spin even faster. So inside a real rotating black hole, immense centrifugal forces stretch that infinitesimal point out into a rapidly spinning ring, a ring singularity.
And because this ring singularity is spinning at such a fantastic, furious pace, the centrifugal force acts like anti-gravity. It literally pushes back against the infalling matter. This creates a terrifying, invisible boundary just outside the singularity known as the Cauchy inner horizon. As radiation and matter fall in, they get pushed back by this anti-gravity and they pile up. Because time dilation here is so extreme, it acts like a cosmic fast-forward button. If you were to hit this inner horizon, you'd experience what physicists call mass inflation. Every particle of light, every ounce of radiation that has ever fallen in or ever will fall in over trillions of years would hit you all at exactly the same time. You would be struck by a wall of infinitely energetic radiation. It's an environment so profoundly chaotic, the math suggests it threatens to destroy the black hole's interior entirely.
Section 5. Quantum Alternatives. Eliminating the infinite.
Now, because infinities in physics usually just mean our math is incomplete, modern scientists are desperately searching for alternatives. And to do that, we turn to quantum mechanics. One leading theory, loop quantum gravity, suggests that space-time isn't actually smooth, but made of tiny, discrete pixels. This leads to the wild idea of a Planck star. The concept is that matter cannot be compressed smaller than the absolute smallest pixel of space, known as the Planck length. So, instead of being crushed into an infinite point, the collapsing star meets an unyielding quantum resistance. It compresses and then eventually bounces back out, which means black holes actually explode. But because of that extreme time dilation we talked about earlier, a bounce that takes milliseconds on the inside takes trillions of years for us to witness on the outside.
Another mind-bending alternative is the gravistar. This theory suggests that dark energy, the same mysterious force causing our universe's expansion to accelerate, actually prevents the singularity from ever forming in the first place. Instead, the infalling matter gets trapped on a thin, super-dense surface shell, while the interior is just a smooth, bubbling core of outward-pushing dark energy. From the outside, it looks and acts perfectly like a black hole. It traps light, it bends space. But deep down, there's no infinite center, just a solid core of quantum energy.
So the crucial point is, we are currently witnessing a massive war in physics. General relativity says the infinite singularity must exist, while quantum mechanics flatly rejects it. And the incredible thing is, we're actually listening to the universe right now to find out who's right. We're using gravitational wave detectors like LIGO. When black holes collide in deep space, they send literal ripples through the fabric of space-time. And right now, the data from those ripples actually makes the existence of gravastars highly unlikely. They just don't ring the way a hollow shell of dark energy would when they crash together. So the infinite math remains beautifully, frustratingly incomplete.
Which leaves us with a final, rather chilling thought. What is really happening inside a black hole? We don't know. And the scary part is that we may never know. The event horizon is the ultimate cosmic sensor. It locks away the universe's greatest secrets in a vault that no light, no probe, and no data can ever escape. Is it a ring of infinite gravity? A quantum bounce waiting trillions of years to finally explode? As we look out into the night sky, we have to ask ourselves, are we prepared to accept that there are places in our universe fundamentally, permanently beyond the reach of human knowledge? Keep that in mind next time you look up at the dark.